Today the topic is three-dimensional geometry, that is unit 4. Now I'll teach you direction cosines first. What is a direction cosine? If any line that passes through the origin, if any straight line that passes through the origin makes an angle alpha, beta, gamma with the x-axis, y-axis and z-axis are called direction angles, and the cosines of that angles are called the direction cosines. Once again I'll repeat, any line that passes through the origin that makes an angle alpha with the x-axis, beta with the y-axis and gamma with the z-axis are called the direction cosines of an angle, and it is denoted by L, M, N. L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Now we will take direction ratios. Any three numbers, let us take that as A, B, C, that are directly proportional to the direction cosines. Any three numbers that are directly proportional to the direction cosines are called the direction ratios. Once again I'll repeat, any three numbers A, B, C that is directly proportional to the direction cosines are called the direction ratios. That is A is equal to KL, B is equal to KM and C is equal to KN. That is K is called the proportionality constant. Now the relation between, what is the relation between the direction ratio and direction cosine? What is the relation between the direction ratio and direction cosine? Relation between DCs and DR. I'll take the DCs as L, M, N and DR is equal to A, B, C. This L can be written as plus or minus A by square root of A square plus B square plus C square. Therefore, similarly M is equal to plus or minus B by square root of A square plus B square plus C square. N is equal to plus or minus C by square root of A square plus B square plus C square. Once again I'll repeat the relation between direction ratios and direction cosine. I am taking L, M, N as direction ratio and the direction cosines are L, M, N and the direction ratios are A, B, C. Therefore, L is equal to plus or minus A by square root of A square plus B square plus C square. M is equal to plus or minus B by square root of A square plus B square plus C square, and N is equal to plus or minus C by square root of A square plus B square plus C square. Now, if two lines are, the condition for two lines to be parallel and perpendicular. In terms of DRs, DR, if two lines are said to be perpendicular, and the direction ratios of the two lines are A1, B1, C1, A2, B2, C2, then the condition for perpendicularity is A1, A2 plus B1, B2 plus C1, C2 is equal to 0, and the condition for parallel is A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Once again I'll repeat, this is the condition for perpendicularity and this is the condition for two lines to be parallel in terms of DR. In terms of DCs, two lines are perpendicular means, if in terms of DCs we are taking this, then the two lines are said to be perpendicular if L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Similarly, L1 equal to L2 m1 equal to m2 and n1 is equal to n2 are the conditions for parallel and perpendicular. Once again I will repeat, condition for perpendicularity between two lines, that is L1 L2 plus m1 m2 plus n1 n2 equal to 0, then it is perpendicular. If L1 equal to L2, that is the direction ratio of the first line is equal to the direction ratio of the second line, then it is said to be parallel. Now, if 2 points are given, what is the direction ratio? Let x1 comma y1 comma z1, let x1 comma y1 comma z1 be the point on the first line. Then x2 comma y2 comma z2 be a point on the second line. Then the dr is x2 minus x1 comma y2 minus y1 comma z2 minus z1. Now we will look into some problem in this.